Okay, start of a new chapter. And I've got some good news in all this, is the pressure sort of releases here for a couple of sections as we basically just define what we're going to do next. That's basically what I'm all up to, is describing what we're going to do next. And that description has been coming for a while, actually. I want to talk about some basic functions you've seen along the way. And the title of this lesson is called Polynomial Functions. And again, it says an introduction, but actually, that's not really true. Polynomial functions have been introduced to you already. You've seen some polynomial functions. Let me show you some polynomial functions you've seen already. And actually, not just seen them, you've really explored them. You've looked at y equals mx plus b. That was a polynomial function. And the reason it's a polynomial function is it has x's and numbers in it. Okay, well, maybe y equals mx plus b is the general version of it. You saw things like y equals 3x minus 7, y equals 2/3, x plus 8, stuff like that. That's what we did in grade 9. We were already introducing polynomial functions, but we stuck to ones that had exponent 1. We stayed away from anything with exponent 2 or anything like that. Then grade 10 came along. Grade 10 came along, and we expanded our list of polynomial functions we could look at. We looked at y equals ax squared plus bx plus c. A new polynomial function, now called quadratic. It had exponents 2. Today we'll start calling that degree 2, because it has an exponent of 2. And here's some specific ones. You looked at things like 2x squared minus 6x plus 7, or y equals negative 3x plus 4 squared. Something like that. Let me move that over. Y equals 3x plus 4 squared minus 1. Something like that. Those came in two different versions, and you had to learn to factor and quadratic formula and all that stuff that came out of there. And at the end of that, if you were right with it, and you saw what was coming, you go, so what's next? Now we're going to do x cubed? And the answer is, yeah. And in fact, this chapter, I'll give you the weapons it takes. It took us a whole year to do degree 1 linear functions. It took us a whole nother year to do degree 2. This is going to take forever. No, it's going to take about one more day. I'll give you the weapons now that we'll be able to do degree anything. We'll be able to handle any degree function. Why do we care about polynomial functions? Well, halfway through, you'll see, I'm going to bring up the graph of coronavirus cases and a little stock market graph, and you'll see where all this is finally going, what the plan is. So, introduction to polynomial functions. What we mean by that is introduction to getting past degree 2. It's not as bad as it seems. I believe it, that doing the rest of the degrees is easier than doing degree 2. All the work you did to do degree 2, what I'm going to show you is going to make your life a whole bunch easier. Is there a little work to do in between? Sure, yeah. Pointer options. I want laser pointer. There, laser pointer. Okay. And now my controller should be in. Here we go. So, definition of a polynomial function. The definitions, if this messes you up, it shouldn't. All I'm going to say is, from now on, we can do x cubed, x fourth, x 5, whatever you want. But here's some crazy definitions to lay it all out first. A polynomial is an expression that looks like this. It'll have a constant term, an x term, an x squared term, but maybe more. X cubed, x 4, x 5, x 6. We won't get much past x5. Once we can do x5, we'll realize we could do anything. Reminds me of this screw x cube. This one always boggles people's minds. It's a 10 by 10 cube, and everybody goes, how can you possibly do it? The facts are, if you can do this, you're not far off doing this. It's a lot of the same stuff. You just have to repeat a lot. That's the same with degree 3, degree 4 functions. If I give you a degree 4 function, you do the same thing you do with a degree 2 function. You just have to do it a couple more times. That's all. So it's just a lot of repeating here. So this is specific. The powers have to be whole numbers, though. Like we'll do x squared, x cubed, x power 4. We won't do x to the 3.2. We're not going to do any of that stuff when we're doing polynomials. Is it possible to do those things? Yeah, but we're not going to do that. We're going to do polynomials. These numbers here have to be whole numbers. But the exponents can be any, all of the exponents are whole numbers. And the coefficients, though, can be any real number. Any number you want, you can use as the coefficients. So as we go along there, we'll generally keep them behaved, though. Okay? What's a real number? A real number are all the numbers you can think of. Decimals, fractions, whole numbers, positives, negatives, everything that you are used to right now. Is there not real numbers? Yeah, there is. There's numbers that we haven't started to use yet. You don't really see those unless you go into specific applications. So just leave those on the shelf for now. For now, we'll stick with real numbers, which are all the numbers you can think of right now. After one slide, you did a whole slide just to tell us we're going to do x squared, x cubed, x4, x5 now? I'm like, yeah, pretty much. This is the technical stuff, but that's pretty much all that slide says. Some examples, and I opened with examples to frame it so you didn't have to wait till here. Here's some examples. Here's some polynomial expressions. There's x squared, so that's something like shaded at grade 10. Then there's x to the 7th. You see there's one that's a polynomial. Technically, we haven't been able to analyze it before, but I'm telling you, by the end of this chapter, you'll be able to analyze it pretty easily. There'll be a set of steps. Do this, do this, do this. Done. This one, an x cubed function, but notice it's a fraction out there as the coefficient. So the coefficients can be weird numbers, but the powers aren't. Really weird coefficients here. We won't really do anything with weird coefficients, but just to show that you could do weird coefficients, but not weird exponents. You see, x squared, x cubed. 3x minus 5, straight from grade 9. These are all technically polynomials. This is a nice polynomial. It's all factored already, which makes it easy to work with if it's factored. We'll get to that. Over here, here's some ones that aren't polynomials. We won't do them at all. Square root, we're not going to do square root this chapter at all. We're not going to use fractions with the x's in the bottom and stuff like that. We're not going to use negative powers. No rational expressions like this. No, we're not going to. No x's up in the power. No sine or cosine. No x squared multiplied with y's. No crazy exponents. None of that stuff. Well-behaved stuff. Whole number exponents, and then the coefficients can be whatever. But even those, they'll behave pretty well in this chapter. After 2 slides, you're like, okay, I got it. We're going to do x cubed, x4, x5. I got it. Yeah. That's what I'm saying. There's a lot of technical stuff here, but really that's all that's going on here. Notes. A polynomial can use a variable other than x. We often use x, but again, you've already seen some examples where we use t or n or whatever you happen to be working with. Here's one. 2.4t cubed minus 7t squared minus 5.5t plus 1. This is a polynomial because the exponents are all whole numbers. 3, 2, 1 there, and then technically 0 here, like a 0 exponent, but it just means a whole number there. Questions so far? Again, it could be like, so you're just grabbing everything from high school now and gathering it all up and going, okay, this is what we're going to do. That's pretty much what these first 2 lessons are. It's just gathering up everything we've seen so far into one lesson. Polynomials can have more than one variable. Example, this one had x squareds, t's, x cubed, and t squareds all mixed in like this. We just won't do things like that yet. They're not that hard to do, but we just won't do anything like that. How does stuff like this come up? Well, I would say the traffic density between here and Toronto has multiple variables. One, how close you get to Toronto affects how much traffic you're going to see, but also what time of day. So it matters how close you are to Toronto, but it also matters what time of day you're going, how much traffic you're going to get. So there are things that change not just with where you are, but when you are. But actually, once we can master the stuff here, jumping to that is not really a big deal. But we just won't do it here. We'll stick to polynomials. You're beating that to death on this side. Yeah, I am. Simple polynomials. That's what we're going to do. So some more words to help us. These words will actually help us describe things. The degree, I mentioned that before, is just the highest exponent that you see. Example, when you get this one, 7x cubed minus 12x squared plus 5x minus 8, the degree we'll say is 3. We really want to, before we start a question, we want to go, what degree are we talking about? And that'll help us decide how we're going to approach what's going on. So this one's degree 3. Leading coefficient, we're really, really going to care about the leading coefficient. You've already seen this for parabolas. That leading coefficient told us whether it opens up or whether it opens down. It's a big deal what that leading coefficient is. And the leading coefficient is the coefficient of the highest power. So in this previous one I just did, the leading coefficient would be that 7 out there. And that's going to matter. It's really going to help us. And you'll see, by the end of the next lesson, you'll really see why that matters. Here, the leading coefficient is that 7 out front. So 2 important words. We can do a lot of the work we have to in this chapter just from the degree and the leading coefficient. We'll know a lot about the graph as long as we know the degree and the leading coefficient right off the hop. Polynomial function, nothing special here. It just means a A polynomial function is a function where the rule is a polynomial. So here's a polynomial expression. And here comes Magic Mickey to turn it into a polynomial function. You ready? He's going to turn it from a polynomial expression into a polynomial function. You see what he did? Next to nothing. Did he? Oh, here he goes again. He's ready. It's an expression, and bing, now it's a function. That's all. So they're slightly different in terminology, but honestly, I'm not setting up to trap you here. I'm really not. There's not going to be on the test like, oh, is this one an expression or is it a function? I'm just trying to get the terminology down so you know what they're talking about when they mention these things. Okay, so hey, here we go. This is getting you ready for the homework right here. If you can do this, you're well on your way to some of the homework questions here. The degree and the leading coefficient. Quiz yourself right now. Think about what would the degree of this be and what would the leading coefficient be. Start with degree. What's the degree of this thing? 4, not too complicated, right? So again, this is 2 steps up in the progression. Grade 9, degree 1, just had x's. Grade 10, degree 2, x squareds, and now we're going to start looking at things with x to the 4th. So the degree is x to the power 4, and what's the leading coefficient? The -8. We're really going to care about that thing. So those words, they get you to practice that once in the homework to go through and see if you can remember what these words mean. Degree 4, they tried to trick you, right? You know what? If they give you one like this in the homework, don't even do anything. Don't even read the question. Just write it in the right order to begin with. Yeah, get this one first, then this one. Write them in that order so it doesn't mess you up. Degree is 4, and what that means is the leading coefficient is 1. Yeah? Degree. Keep looking. 3, 5, and 7. And this can be frustrating. Like, why would they even write it like this? Stupid. Write the highest degree first. And I totally agree with you. Yeah? When you get them, as soon as you get given one like this, just write it in reducing degree order so it's easier to see what's going on. So the degree here is 7, even though they put the term last. And the leading coefficient is this -4.1 sitting there. Excuse me. There we go. Any questions about those? Examples of polynomial functions. Okay, and this just is completely reviewing everything I've just said. Setting up the whole lead up that started when y equals mx plus b started in grade 9 and ends at the end of this lesson. Like, what are we going to do next? So, degree 0 are constant functions. Just straight lines like that. Those were actually, we did them as special cases of the line in grade 9. Degree 1 were the linear functions like y equals x and y equals -2x plus 5. They look like this. Yeah, so grade 9, straight lines. Then grade 10, we called them quadratic. Degree 2s, they'd have y equals x squared, y equals -2x squared, and you'd get some kind of parabola. And this is where factoring, quadratic formula, all that stuff came out of. Okay? So, now we're at the end of grade 10. Now, first introduction to what degree 3 might look like. Degree 3 is called cubic instead of quadratic. That's the next name there. Because they're cubed, the power's cubed, y equals x cubed. And so they can look like this now. You can have x cubed by itself, or you could have x cubed and x squared terms and x terms. There's all different mixes here. And you're like, well, what am I going to do with all that? Nothing. It's going to take me all the way till Thursday afternoon to be able to get all the little pieces it takes to really analyze this. Today it's just an intro. What might this sort of look like? It might just look simply like that, or it could look like this. And something crazy like that. Now, what's the difference between that and a quadratic? A quadratic has one extreme value. The next level up might have 2 extreme values. So you get an extra bump or hump. Could have, might not have, but could have, up to that many. Yeah. Degree 4, we call it quartic. I've never once on a test made it that you had to know these names, by the way. You could call them degree 4. I put the names up there on the off chance in a homework question they go, oh, it's a quartic, and you have to look up what it is. But I never really got hung up on that. We call them degree 4. That's the easiest thing to call them, is degree 4. And so you could have a simple one, x to the 4th, but you could have a crazy one that had x 4th, x cubes, x squareds, x's, all the different terms in there. And what's going to happen with the graphs there? You could get up to 3 bumps or humps in there. And so it gets a little more complicated. You're like, well, how am I going to find these bumps and humps? How am I going to find these zeros and stuff like that? Yeah. All chapter. We got all chapter to figure those things out. Actually, today all we're going to figure out is whether they go like this or like that. Or we're just going to find the ends, like what happens out at the ends of these things. And one more, quintic. Could be pretty simple, but it could get right crazy. And it could have up to 4 bumps and humps. And you're like, well, how am I going to find all this stuff? We got all chapter to figure those things out. This was just an intro. This is what the graphs are going to start to look like. Instead of one simple little swoop like that, you could get multiple swoops and bumps and everything like that. And finding these things, actually, I'll have a procedure. I'll have a procedure by the time the chapter's over to go, now we can find exactly where these things are. I won't say it's perfectly straightforward, but there'll be a set of steps. You know, it'll be like, do this, do this, do this. How high can we go with degree of polynomial? As high as you want. You can go up to degree 100 million if you really wanted to. So there aren't any common names that we use when we get to higher polynomials, but we'll spend most of our time on degree 5 or less. In fact, even the degree 5, you won't see until I show it to you. Really, a degree 5 will pretty quickly make it into a degree 4 and analyze from there. So don't worry that I'm going to suddenly drop a degree 88 on there. I wonder how the coefficients affect the shape of the graph. Okay, I just want to show you a quick little demo in Desmos that can show you what these functions can look like. Okay, so the first one I want to do is the linear function. So here we go, reviewing grade 9. Ready? You could have all sorts of different y-intercepts. Do you remember that? Y-intercept is how high or low it starts. And you could have all sorts of different slopes. Good grade 9 review? That was linear functions. Then quadratics came along. And you could have all sorts of different a values, which affected the shape here. And the b's and c's made it so that you could move this thing around. And if the a went negative, you could flip it over. Yeah? Pretty good review of grade 10? That was the whole deal. Move this parabola around and maybe flip it over. There's all sorts of algebra that happened. I'm not saying that it was simple, but that was the deal. So, now, the big moment. What could cubics look like? I'm going to take these a values and I want this a value to be 1. I'm going to put these back to 0. Is it going to let me get 0? There it is, 0. And then this one back to 0. Okay. And here's the basic cubic. Not much more complicated than an x squared. It opens,